You know that the converses of Theorem 6.3, 6.4, and 6.5 are true. Using what you've learned, you can show that the converse of Theorem 6.6 is also true. Theorem 6.11 states, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if segment AE is congruent to segment CE, and segment BE is congruent to segment DE, then quadrilateral ABCD is a parallelogram. Theorem 6.12 suggests that if you keep two objects at the same length parallel, such as cross-country skis, then the quadrilateral formed by connecting their endpoints is always a parallelogram. Theorem 6.12 states, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So if segment BC is congruent to segment DA, and segment BC is parallel to segment DA, then quadrilateral ABCD is a parallelogram. Problem 2. Deciding whether a quadrilateral is a parallelogram. Can you prove that the quadrilateral is a parallelogram based on the given information? Explain. A, we're given that the length AB is 5, the length CD also 5, the measure of angle A equals 50, and the measure of angle D equals 130. We're asked to prove quadrilateral ABCD is a parallelogram. So consider whether or not that can be proven. And the answer is yes. Same side interior angles A and D are supplementary. So segment AB is parallel to segment CD. Since segment AB is congruent to segment CD, quadrilateral ABCD is a parallelogram by Theorem 6.12. How about B? Given segment HI is congruent to segment HK, that segment JI is congruent to segment JK, prove that quadrilateral HIJK is a parallelogram. Consider the diagram and the given information. No. By Theorem 6.8, you need to show that both pairs of opposite sides are congruent, not consecutive sides. Your turn. Can you prove that the quadrilateral is a parallelogram based on the given information? Explain.